So we're carrying on with our discussion of connected and static routes. We've just set up a static route from Jake over to Jane, and we have pinged an address that's over on Jane, and we've got a response back. Now, some of you that have dealt with routing before may have said, well, you didn't set up a static route back to your 10.1 networks over on Jane, so how did the traffic get back to you? It's because when you issue this ping command, the ping command by default uses the interface that is closest to the next route. So it sent out the ping requests with a source address of 192.168.1.1. Obviously, Jane knows how to get back to that because, again, directly connected route. So it pinged one of the loopback interfaces over here and just sent it right back to this 1.1. If we were to ping with a source address of 10.1.1.1, for example, the pings would fail. And let's do exactly that. So we'll do ping, and we'll use extended ping commands. And this is also a good troubleshooting method so that you can ping from a specific subnet that's defined on the router. So we'll do IP. The target IP address will be 10.2.1.1. 5 pings is fine. Timeout in 2 seconds. Yes, we'll use extended commands. Source address or interface will be 10.1.1.1. Now that source address or interface has to be a valid address on the router. You can't do 10.1.1.7, for example, in this case, because that address doesn't exist, and it'll tell you you can't ping from that. And we'll leave all of the defaults for the rest of the options. And you'll notice that now our pings time out because Jane does not have a route to get back to the 10.1 networks over on Jake. So we'll build this reverse route over on Jane, and then I will pause the video while I build all the other reciprocal routes, if you will. So let's go over to Jane. Let's verify that the routing table doesn't have anything untoward in it, and there it is. It's still all directly connected routes. So now what we're going to do is we're going to do config t, and we're going to enter pretty much the same command over here on Jane that we did over on Jake. So we'll do IP route 10.1.1. Actually, we're going to do a summary. So we'll do 10.1.0.0 with a net mask of 255.255.252.0. And the next hop for all of those networks will be 192.168.1.1. 192.168.1.1. So now, if we go back out to the privileged exec and do a show IP route, we now have a static route that's a summary route for all of those networks. So now, if we go back over here to Jake, let's do that same ping again from 10.1.1.1 to 10.2.1.1. So IP, target IP address is 10.2.1.1. We'll use extended commands. Source address will be 10.1.1.1. Take all of the other defaults. And now our pings are successful because Jake has a route to get over to Jane. Jane has a reciprocal route for those networks back over on the Jake router. So now we'll pause the video and we will enter all of the routes on all of these routers. And now that all that's done, we can look at the routing tables and we can test our network here. So now we're over on Roxy. That happens to be the last router that I configured. So we'll do show IP route. And you'll notice that we have our connected routes as well as 2 static routes for the 10.2 and the 10.3 networks, both pointing at 192.168.1.5, because from Roxy's perspective, that's where both of those networks live, behind the Jane router. If we look at Jane, Jane's routing table actually is a little more complex than Jake's or Roxy's because it has routes for the 10.3 network going out one interface and the 10.1 networks going out the other. So now we should be able to go over to Jake and do ping 10.3.1.1, which is one of the networks that's over here on the Roxy router. It's the loopback 1 interface, to be specific. If we do that from here, well, our pings failed. Why did our pings fail? Again, going back to what we discussed before, the pings are sent with the source interface address of this .1. Well, Roxy doesn't know how to get to the 192.168.1.0/30 network, or does not know how to get to this interface on Jake, so the packets get to Roxy, but Roxy doesn't know how to send the traffic back. And yes, I actually did that on purpose just to demonstrate this. When you build static routes, you have to remember to put every network in your static route table, including your point-to-point links, because you never know when you're going to get traffic that's sourced from those addresses, especially if you have any kind of NAT going on your network. And this is why, especially if you've watched the IC&D1 course, you'll see that I say static routes should be killed with fire every time you encounter them, because this is an administrative burden to keep track of all of these routes. What if, for example, you took this 10.3.3.0 network and you moved it over here to be on Jane? Now you have to go update the route tables on Jake and the route tables on Roxy, and you can no longer summarize, so now you have to go build individual static routes for each of these networks on Jake and Roxy, as well as however many other routers you have in your enterprise. But enough of my evangelizing about static routes. Let's actually do the extended ping like we did before and show you that it actually works like it's supposed to. So we'll just do ping for IP 10.3.1.1, and we'll use extended commands. The source will be 10.1.1.1. And now the pings are successful because it's being sent from a source interface that Roxy knows how to get back to. So hopefully this has taken you a little further down the road to understanding connected and static routes. And that concludes our discussion of connected and static routes.